Hello everybody and welcome to this Oracle Code online session. In this session we're going to talk about how to build a blockchain solution in around 45 minutes, and we're going to use the blockchain cloud service for this. So my name is Robert van Mulke. I'm a solution architect and a developer, and I'm mainly focusing on blockchain, IoT and cloud native applications. I'm a Groundbreaker ambassador and also an Oracle Ace. In the past years I've wrote 2 books, one about Oracle integration, cloud service, and one about blockchain across Oracle industries. So if you are interested in one of these topics, you can check out the books on both Pact and Amazon. You can also link me on LinkedIn or follow me on Twitter. So this is a little bit of an introduction on the book. If you're really interested after this session, the book will go over a full introductionary on blockchain and how it will affect you as a developer, but also your customers. It goes over all the core concepts, and with those concepts we're gonna implement our own blockchain network. So you learn how to design, develop and run smart contracts on the Oracle Blockchain Cloud service. It also will go into some industry analysis for finance, governance and healthcare. So if you're interested, you can check it out. So let's get to the agenda of this session. So we'll first start with a recap on what is a blockchain. Tell you a little bit about the decentralized blockchain applications that you can build on top of the blockchain. I've got a nice introductory suitable solution for using blockchain. A little bit go over what we need to run this business solution, and at the end I will show you how to build this solution, this blockchain solution. So let's start. So what's a blockchain? So a blockchain is also called a distributed ledger technology, or DLT in short. It's a digital system for recording transactions of assets in a list that can be replicated across available nodes in a network, and it does that redundantly and rather than being stored right in a central data store like a traditional database. The ledger records all transactions that are submitted to the blockchain that are successful. It holds the raw data and also so the whole data of the transaction, and also some information about the nodes or the participants that submitted the transaction. The more evolved blockchains, the enterprise blockchain, also keep a separated key value database with the current state of an asset. So the latest values. It's a decentralized peer-to-peer network of nodes, and this means that the data is distributed to all nodes in a trustless manner using the peer-to-peer protocol in near real time. It uses a combination of digital signatures and also public key cryptography to prove your identity and also your authenticity, and it enforces read and write and execute permissions, so the access rights on things you can do on the blockchain. It makes it possible to permit write access for certain participants, but you can also give read access to or read access to a wider audience. The last thing here is that any transaction added, it needs to be validated by multiple entities. So in the network, the transactions are distributed, and then the majority of the nodes in the network needs to agree, so reach consensus on what is submitted, and it does that following network rules, but also rules in a smart contract. So in this case, you can see that blockchain is a little bit like digital trust and transparency. But I've also always one thing that you need to keep in mind, and that blockchain alone is not a technology that can magically fix our first world problems on its own. It requires a combination of aligned business processes. There's where we need to start, right? We need to form a consortium, or we already have that consortium, because maybe we already have a B2B digital solution that we might want to replace. But it needs business processes. So what are our business transactions? What are our business documents? Besides that, we have code. We need we need a smart contract to act like the backend to give access to the ledger or stores information into the ledger. In most cases, we might need IoT, so to have scientific sensors registering certain values directly into the blockchain. And at the last, we might have a combination of AI and machine learning to do some complex stuff before we put something into the blockchain. So next, we're gonna look at what. So we talked about blockchain. Now let's look at the layer what we can build on top of that. They are called decentralized blockchain applications, or in short, a DApp. So a DApp is a blockchain-enabled web application. It runs on a peer-to-peer network of computers rather than a single server. And in this case, smart contracts are allowing it to connect to the blockchain data. It contains, in the ideal world, both front-end and back-end, and it runs independently on all nodes. So what does a decentralized app on the blockchain look like? So the backend is powered by smart contracts. And smart contracts are agreements between parties with automated execution. And they can act as a complement or even a substitute of legal transactions and legal contracts and business transactions. A smart contract is basically computer program code, and it's capable of facilitating, executing and enforcing the negotiation and performance of an agreement. And at the right you see an example of a function within a smart contract, and with this function we can place an order to buy a vehicle. And this vehicle is the object that is received. The data is checked if everything is in order. It also looks into the registry if it doesn't exist, and it can add it to the registry. Once it's successfully added to the registry, it creates an event object and emits that event. So a web application can react on the event that is sent out. Besides that, a decentralized application also includes, I think one of the most important things is the data model, and that describes the participants, assets, transaction and optional events. Participants can be network participants, but in the case of a decentralized application, so like the smart contract, it describes the users within the application itself. Basically, with this we can define a role-based access and maybe even set up some access control list on certain functions of a smart contract. The assets, they are describing what we want to store on the ledger. Transactions are the methods to store, read and transact assets between participants. And events are triggers for we can send out for the application, so it doesn't have to query on the data, but it just can listen to events to do their following action. Next to the data model, we have a authorization and permission model. So based on the participants we define, but also the network participants, we need to define an authorization and permission model, so who can read, who can write, who can execute certain or write certain data, execute certain functions on a smart contract. Then we have APIs, which let the front end connect with the back end to make it easy for the front end to get the data out of it or store the data in the blockchain. And the front end, the web application, it usually runs outside of the blockchain. In the case of blockchain cloud servers and Hyperledger Fabric, it can't run in the blockchain. There are some platforms that allow a web application to run on the blockchain. Okay, next, let's look at what is a suitable solution for using blockchain. If we look at the business value of blockchain, we see a lot of use cases that it reduces fraud and risk, and it does it by giving end-to-end tracking and instant visibility on all the transactions. In a traditional way, and we see that in a moment in my example, is that with a traditional B2B solution, usually it's not a one-to-one transaction that happens, but there's a broker in between that. The broker receives a message from a certain party and then sends it on to maybe multiple parties. But all these organizations, they have their own node, which you don't have end-to-end visibility. And with blockchain, every organization is part of the same network, so we can see all the transactions happening there and all the actions on the transactions. So it reduces audit costs if something needs to happen. It also improves data quality and it avoids reconciliation and manual exception handling because all the organizations use the same smart contract. So instead of building your own middleware and backend, all the organizations use the same smart contract. You decide on it, and then you don't have to maybe email or call certain organizations if something goes wrong. Besides that, it reduces the cost and the risk of using intermediaries. Now, in the standard B2B, if we have the brokers, they have some control in this whole situation, and everybody needs to trust that intermediary. And the trust of an intermediary will cost some money in this. And also increases like the business success, and because we see all the transactions, we can have better trust and transparency, and it enables us to create new business models for that. And because it's you only have to create a smart contract together, and then not everybody needs to have their own like middleware or backend or any processing of APIs. If you want to share information, it really lowers cost of software, using software, those software for each organization. Okay, let's look at the traditional solution. So in this case, we have a lot of organizations working together. If we are doing part of an insurance claim process in this case. So let's say I own a car or drive a car, but it's not my car, it's a company car. So I lease it from a lease company. I am the driver, so it's registered that I'm the driver, and I'm even on the insurance policy itself. I'm named there. The insurance policy is of course of an insurer, and in this case what I want to show you is, let's say that I've got into an accident, and it's a fairly heavy accident where we might need police to come by to maybe help make up the report. So in this case, if an accident happens, if you have a luxury car, the vehicle might call the police or the emergency service itself. But in many cases, I need to call and tell them what happened, and they make a report about it, or they come to the location and then they make a report about it, what happened. This report is not shared with the lease company, so I need to call the lease company, tell them what happened, and they ask me to fill in the European insurance form, and that is shared with the lease company, but also with the insurer. It might happen that I even need to call the insurance company to tell them more clearly what happened. Then the lease company says to me, okay, you can fix your car, you can fix it in this repair shop, and then I make the appointment myself when I have the time. So I call the repair shop, and the first thing that the repair shop is saying, I need to check with your lease company that that it's fine that I can fix your car. When a lease company does a insurance claim to one or multiple insurers that are involved in the accident, then the insurer also needs to approve the repair quote, and there's a lot of action between all these organizations. In a really traditional way, it's email-based, paper-based, and something like that. But let's say we have a more electronic, digital solution that uses B2B. And in this image you see a lot of organizations working together. So at the right we have the emergency call center, right top, and then at the left top we have Autolease, that's the lease company. At the left side we have some repair shops, the automotive services, and at the right side we have two insurance companies. In the middle there we have the broking service, Acme Insurance. What happens here is that all the messages between the organizations, so the partners in the network, will go through the Acme Insurance broking services. So in the image you see all the organizations implementing Oracle Fusion Middleware B2B, so the B2B software to transact digital messages together. So they use EBMS and EBXML as a protocol, and they have some contracts there. But everybody needs to build their own middleware and backend and maybe a database to store it on. So in this case, what can happen is that if Autolease is sending out an insurance claim through the broker that needs to be received by the two insurance companies, the broking service needs to do that, and it needs to have that mechanism there in place. But in a traditional B2B solution, you have maybe a functional document describing the business transactions and the messages going over the line. But both insurance companies need to process the message themselves. So they need to have logic there, they need to develop some stuff, and they need to implement those business rules. But in many cases, they might not want to, or not implementing all the rules. Maybe AllSecure will do all the rule or implement all the rules, but the other insurance company doesn't. Usually in a business transaction, an acknowledge or fault message needs to be returned. So if one will implement all the rules, it can maybe send out a failure message because something in the request message is wrong. But the other insurance company that doesn't implement all the rules can send an acceptance message back. Then the Acme insurance broker doesn't know what to do anymore, so the message is stalled there. Might be that Autolease needs to have a response back within 24 hours. So what's now, right? They didn't get a message back. what they are need to do, what they are going to do is call the emergency or call the insurance company, or maybe the first one, all secured, asking, okay, did you receive my claim or not? And they can say, yeah, we received it, and we send a failure message back because something was wrong, or we don't know. And then the other and then you send a response back. We maybe need to go to the broking services and ask them what happened, and maybe it's even possible that we need to call the second insurance company to know what happened. So there's a lot of offline reconciliation needed if something goes wrong. So let's look at how we can solve that within blockchain. So instead of having all the lines going from one organization to another, in this case, we use a smart contract. So, and all the participants will do actions on the smart contract. So let's say I've again in an accident, and the vehicle has an IT sensor in it, so the luxury car, and it can send a message directly to the smart contract to register an accident based on the location. The smart contract can act on that and store it directly into the blockchain. And once it's done that, it can set out an event where that is received by the police or the auto lease company, or and the interested participants there. If somebody makes up a report, maybe the police or I call the lease company, and they fill in the report, then that report is shared through all the organizations, because the creation of the report is done in the smart or by the smart contract. So all the actions are done through the smart contract, and the data is stored on the ledger on the blockchain. So if we then look at how the infrastructure would look like, we see that in the middle we don't have the broking service anymore from Acme, but we have our blockchain network of all the organizations and the nodes. So the organizations all have their own node, which are connected to the same blockchain network, and all these nodes have the same smart contract and the same distributed ledger. So this one single truth of the information. Instead that all the organizations have their own middleware and backend, maybe it's enough to just have some UI or an application that's connecting to the REST proxies, or REST proxy, or through an SDK directly with a node to let's say connect to the ledger, or store information or query information on the ledger. And it's all done by calling functions on the smart contract. So that was the solution also I want to show you in a moment in the demo. But let's go over what we need to run our solution, right? This solution that I explained. So for this, we're going to use the Oracle blockchain platform. And the Oracle blockchain platform is a fully pre-assembled managed service. It's built on top of Hyperledger Fabric, and that's a distributed ledger framework. And with it, we can securely extend our already existing business applications, right? Maybe and processes. Maybe we have something in ERP, or we already have a front end and things like that. And it's really used to accelerate transactions across partners in one ecosystem. It includes smart contracts and also permission channels. We will see that in a moment what it means. Further, they built some services on top of that. It's easily to plug and play with other Oracle SaaS solutions using Integration Cloud. And it also has some automated operation for provisioning environments, creating new nodes, connecting organizations. So what I mentioned, it's built on Hyperledger Fabric. And Hyperledger Fabric is the framework they use as an engine. It includes a ledger, it allows for programmable smart contracts, and it is a distributed system by which the participants of the network share transactional data. Hyperledger Fabric is a permission blockchain, so this means that you need to have a user account on it to even do like calls to a smart contract. It does not require or use cryptocurrency to keep the network running. It uses a different consensus model with better performance. It's a voting system, so it doesn't do any mathematical equations. Every organization or every node in the network that's part of the endorsement or consensus mechanism, they execute transactions redundantly. They share the result with each other, and based on like a voting system, they choose the majority if a transaction is valid. So the amount of nodes are generally very stable due to the fact they are all transacting together, right? A business can only be part of it if they are really participating in everything. And the new members of the network can be enrolled to the membership service provider, and this is for Hyperledger Fabric the case, and even with Oracle Blockchain Platform, it's all done by Identity Cloud Service. Fabric uses a modular architecture, so it allows for several pluggable components. We can store data in multiple formats or different kind of databases, and it has switchful consensus mechanisms. So maybe in the future we have better performing, maybe even consensus methods or different ways, or even you want to have like more stricter consensus method. Fabric allows it for that. It's on the platform provider to use those functionalities. It's a scalable implementation, and as it uses Docker containers to run, so you can easily scale up new nodes and join the network. It offers the ability to create private channels. This means that if you have like 10 organizations within a network, you can even create a channel that only includes 5 of the 10 organizations. So let's look at the components of Hyperledger Fabric before we get into the blockchain platform. So at the left you see the components. The first one is the validating nodes and peers. You see that at the right in the image we have 3 validating nodes and peers. As I shown in my example, they each all have the distributed ledger, which is the single version of the truth, and it includes smart contracts. And in Hyperledger Fabric, they are called chain code. Then we have an ordering service in the middle. The ordering service handles the consensus mechanism. So it collects all the votes on the transaction, and then it knows what the majority is saying, and it allows for the committing the transactions and reaching consensus. Then we have a membership service, and with the membership service we can create users or organizations that part of the network, and it allows for role-based authentication and access control lists. So if you use Hyperledger Fabric, you need to bring your own identity management, fault tolerance, you need to do container lifecycle management, you need your own configuration and monitoring tools, that's not included. If you want to have recovery, you need to have failover of components, you need to configure that and manage that. Also scaling, and if you have data recovery, you need to do that. So how are you going to do your backup of the ledger and even the configuration information. If you then look at the components of blockchain, you see that it starts with Hyperledger Fabric, so it has those same components, but the added value, you see that already in the picture, as we have a REST proxy that we can call to call the smart contracts. If you use Hyperledger Fabric, you can only do that using the SDK, but with blockchain platform we also have a REST proxy out of the box. You also see some other stuff in the image, like we can do something like SQL, but let's go over that, right? So what's the Oracle added value here? So it's a pre-assembled environment, so all the dependencies are pre-assembled. So if you like provision an environment, you get all those components out of the box for you installed. So it has a REST proxy to call smart contracts, but it also has operational APIs. So you, even with using the REST service and maybe your own DevOps tooling, you can also configure and monitor the whole blockchain. It comes with admin and operational consoles we can use. That makes it very easy to provision. I will show you that in the demo. And it has integrated. It integrates very well with other SaaS application on-premise solutions based on connectors Oracle provides. It can do rich integration by offloading ledger data to data warehouse, and it also provides SQL-based rich queries in the ledger itself, in the key value ledger. That is not something that Hyperledger provides. Hyperledger provides the rich queries using a JSON style search, Oracle provides an SQL-based query. Besides that, it integrates very well with DevOps, and it makes it very flexible. Okay, this is the platform architecture itself. In the middle you see the open source Hyperledger Fabric framework. That's just a small layer of the solution. Everything runs on the Oracle infrastructure and PaaS services. And on the ledger, they build their own REST API. They modified the SDKs a little bit for Go, Java, and Node.js, and they built some Oracle Integration Cloud adapters. With these layers, it's very easy to connect Oracle SaaS and also custom cloud applications and on-premise apps. The services on top of Hyperledger Fabric provides a lot of governance on top of that, which is coming very soon, better confidence. And also the way you do confidentiality and consensus. They modified a lot of that. You are able to connect Hyperledger Fabric peers itself, so the standard Hyperledger Fabric peers that maybe are running on a third-party cloud like Amazon or Azure or even on-premise. And then in this year they also will provide satellite nodes, so they are separate nodes you can install, so you don't need an environment. You can run the satellite nodes on any cloud you want, but they are modified to work better with the Oracle Blockchain Cloud Services. And they also are updated, and they have certain features that Oracle provides for satellite members of the consortium that don't want to run in the Blockchain Cloud Service itself or on Oracle Cloud itself. Let's look at a sample solution here of an architecture. So we can see the Oracle Blockchain Platform with all his their added value. The Blockchain Cloud Service at the left, you see a connection to the Oracle database and ADW, that's the data warehouse cloud. We can offload ledger data, so we can do rich queries. If we want to do analytics on it using Oracle Analytics Cloud and to make dashboards on the data, then querying the ledger itself, the key value ledger, is not that performant. So with this you can offload it to export the data to something else. It provides a console for admin and operations. We see that also in the left bottom of this image. And then on the top we see a portal application view, so we can use Oracle application container, or we can use Kubernetes Engine Cloud to run our custom front-end applications on top of that, or even our middleware APIs if we need that. And it's all connected to, if you want to have end-to-end security like SSO, we can use the Oracle Identity Cloud to log into those applications, and also the Identity Cloud is used in the Oracle blockchain platform for our organizations and users of the blockchain. From there, at the right bottom, we see the external SaaS SaaS solutions and on-prem EBS, SAP, and everything, and that can connect to the blockchain using Oracle Integration Cloud. They have a lot of integration adapters for those SaaS solutions, and also using API management, we can connect very easily with REST proxies to have an abstraction layer on that. Because the REST proxy itself is very generic, and maybe we want to use the API management to have better domain object APIs. So let's get to the fun part. How can I start building a blockchain solution? And we're gonna do that with Oracle Blockchain Cloud servers. So in this case, in my demo, I created 3 instances of the blockchain cloud service, and you can do that by going to My Services and then clicking on create an instance, search on blockchain, and then click on the Create button for the autonomous blockchain cloud subscription. Then from there we can create a quick start template. We don't only have to need to fill in a name and it creates everything, or we can create our instance ourselves, so some manual steps. So if you click on create instance, you get this view, this page, where you can give up an instance name. In this first case, it's Acme Services. You can select a region where you want to run it, so you can even decide to run all different organizations in different regions to be a little bit decentralized. At the right side, you can choose some service options like do I need to create a new network? So in every network there needs to be a founder node that starts everything. So in this is Acme Services. They are the first one, and they start the network. You have some configuration in the size that you want to create it, and choose the developer size here. That has a minimum of 500 transactions per hour. If you have more transactions per hour, then there are different tiers you can choose. You have an option to create some peer nodes. This means that if you send out a transaction to a certain organization, the transaction itself can be load balanced to multiple peers. So maybe this can help with performance, but also high availability. If you only select one peer and that peer goes down, then the organization is also down. So for all the organizations I created in this demo, I choose to create 2 peers. Then you can also upload a root CA if you have your own certificate authority, where you can provision user accounts. Or your organization account, but if you leave it empty, then Oracle will handle that for you. So in this demo, I provisioned 3 environments. Acme Blockchain, so that's the founder. The emergency services, ER services, and the third one is auto lease. You can see at the right that it usually takes around 10 to 15 minutes to create an environment. Sometimes it's quicker, but it's usually between 10 and 15 minutes to create an environment. One thing to note before I go into demo: the ER services, auto lease, they in the last screen, I chose for the service option not to create a new network, so they will join the existing network. So that's how we do that. Okay, so let's go to the demo, guys, and let's go to the let's start with the browser. Okay, we can go to this one. Hopefully, I'm still logged in, but let's keep this running. It's in the meantime, let's show you the dashboard of the founder. So this is the founder organization. This is Acme Services. And if you roll it out, you can see I've got one default. You have some summary information here. Like I've got already a default channel. I've got 2 peers. I've got an order node, so that handles the consensus. I've got 0 chain code installed. That's the smart contract. I haven't got that, and I have 0 participating organizations. You see some information here, 100% health, and how it's used. So let's look at the network before we go into. Let's show you the other 2. So I've also got ER services. So this is a separate organization. It isn't joined to a network yet. It has 2 peers, some information, what we do next, and the same goes for Autolease. Let's look. Let's just go to the dashboard. The other one, what I want to show you is you have some cloud details where you can. I would want to show you the environments that are provisioned, but yeah. Let's go to the network. So in the network here, you can see the network summary. It still says no participating organizations. I've got an organization ID, Acme Services. My role is founder, and we can have the ability to add organizations and look at some order serving settings. In this case, what we want to do is add the organizations here. And before we can do that, we need to go to the other organizations first. So let's go to the dashboard of ER services and go to the network. Here we can see that we have ER services, and this is a role participant. A participant means that it doesn't have its own network, it doesn't have its own ordiner. This is a user that's going to join an existing network. In this case, you see also different options. I can only have some ordering services there, so I can't add organizations into this one. But what we need to do is export certificates that we can import in the other network. Then we need to do that for the same for Autolease. We can go to the network, and then in this we can choose to export also the information. So the files are downloaded. Nice thing to know if you want to have an overview of all the nodes in a network, then it's also interesting to export the nodes of those participating organizations. So if I click on nodes in the menu, you can see everything is running. Every instance will have the console running. Created 2 peers, so you can see 2 peers are running. Every organization has its own certificate authority to create users and things like that. And for REST proxies, we see in a moment, we can use that to expose smart contracts to the outside world. So in this case, we are choosing to export peers, and then we can select the peers we want to export. It downloads a file, and we can do the same also for ER services. This has the same setup, so that's also 2 peers. We can select both peers we want to export, and it downloads the file. So now we can go to the network itself, and we can add organizations. So click on add organizations, and then you upload the certificates. Let's go to downloads, and then we can select the certificates for ER services, hit the plus sign at the right, and do upload also the Autolease certificates. Then we click on add, and they are both added. At the background, you see that. We get a new option, export ordering services. We need to import these settings in the other 2 organizations before they are really joined to the network. So let's do that, export ordering services. It will download a file, it gives us a success, and then we can click on finish. The other 2 things we did was export the nodes of the other participating organization we just joined. So we can go to nodes in a moment, because the interesting thing is what I want to show is how the network is made up. So you can switch here between list view and diagram view, and you can see a diagram of the organizations and also the peer nodes and the ordering and CAs and things like that. What we can do here is go to nodes, And then we can see that this one has an extra node, an ordiner, and the other ones didn't have that. But what we can do is import peers and upload the files. So we can upload the both the exported nodes JSON file. We can import it, and then the nodes are added as remote peers. If we then go back to the network, we see it's updated and we see all the nodes remote, the peers there. So this is the network currently there. Of course, the ER service and Autolease has also a CA, but it's not something you can export that information. Okay, the next thing is, so they are now in the same network. They see each other, or in this case, what we now need to do is, in the to participating nodes, is upload the ordering services. And you can see here, go to ordering services. I want to point out, after we imported it, the title here is gonna change. So we're gonna import, we can upload the ordering services. It sees the address that it uses, and then we can submit. The ER services we have done that. We need to also do that with the other with Autolease, the same thing. And then we can say import ordering services, and we can submit. So now all the organizations are joined. The next thing what we need to do is create a channel. So channel is something organization can communicate on, and we will deploy our smart contracts, our chain codes on this channel. What we can do on this page is we see the amount of channels, a list, and then we can say create new channel. This will open this nice box. We can give the name. Let's call it insurance, right? And that. Let's call it insurance chain. We can have some capabilities here, but it's 1.1 and 1.3. So if you want to have the latest version, we can go to we pick 1.3. So that's standard. We want the latest version. We can select in the list which organizations are participating in this channel. So let's select all 3, and then here you can choose the first access control list between reader only and reader writer. Reader only organizations can only see transactions and see the ledger and things like that. They can't execute functions on a smart contract. They can't invoke anything. They can only query data. So let's just keep them on reader writer all 3 for demo purposes. But in this case, we might we can maybe send the one of the peers to reader. But let's create this in this way. So you get a warning, channels can't be deleted. Okay, in this case, that's fine. So in the background now, it creates the channel. So it's now a success, and it does it in an asynchronous way. So it's not visible here. It's now in the background. It's created. If it's created, we get a notification here at the top, and then it will also be visible on this screen. In the background, it talks to the ordiner, and it also sends a message to the other 2 organizations if it's done that they joined this channel. And then what the cool thing is what we're going to see is that they are automatically the channels automatically visible to those organizations. So let's refresh. So here we see insurance chain. It still has 0 peers because it's in the background. It's still working on it. I just manually refreshed it, but if you just wait, right, you get a notification here at the top, and then the amount of peers are added. You can see the notification here that just says, okay, we successfully joined everybody. So in this case, we have insurance chain. We have the two peers. You can see some information here on the channel. The channel itself, we can click through it, and then we see the ledger and blocks and things like that. The code what is running, we can see which peers are there, which organizations are there. And if you are the creator of a channel, you can even do channel policies and access control list in even more detail. But in this case, we leave it like that. This is the more advanced stuff we don't have time for. Let's go back to the channels. Let's go look at the other organization, right? If we go to channels for the ER services, we see that we have the channel here that it's allowed to join, but there are no peers that have joined this for these organizations. So in this page we can go to the hamburger menu at the right and say join peers to channel, and in this case we want to also just join both peers. So they are now joined, they are added here, and we do the same for Autolease. Let's join also both peers. Let's do that. Join. Okay, they are joined. And the next thing we need to do is deploy chain code. Before I do that, I want to show you a little bit the chain code that we are using for this use case. I built this in Go, so I will go over to Visual Studio Code. I use that. They have a really good plugin for building Go applications and also for Fabric stuff. This is the same chain code that would also be possible to run on Hyperledger Fabric itself. So this is not something from Oracle. You see that I've created a insurance chain Go file, and it's the chain code itself. The chain code describes what I mentioned, the data model, the assets, and also the participants. What you have in Go, you create objects like structures, and this is, for example, an address concept. And I call things concept if it's not an asset, if it's like used within a complex structure. So we have an address, we have a location, we have an estimation, things like that. You can have strings, you can have floats, you can have arrays in it. So there's the basic types in Go you can choose. I also have abstract definitions. Abstract definition is something not like a complex structure with a child structure, but this is an abstract is something I include in the object itself. We'll see that here in the insurer. You have a company abstract, and this means that all the fields from this object will be just placed in this structure itself, so it's not a child structure. I've got some participants. They are assets. I can use these kind of assets to do access control lists and role-based authentication and things like that. But we have a registrant, insurers, the emergency services, and also repair shops. So these are our participants also in a network, but also the users of our smart contract. Maybe like a registrant that can be a driver, they don't have an infrastructure node, but they can be a part of a participant of a smart contract and have a user account on the network itself. We see I've got some assets, vehicle assets, accident reports, quotes, quote requests, repair quotes, insurance policy, insurance claims, and a lot of stuff there. Also some specific structures, objects for events. So that are the events that I send out when something happens and something is stored on the blockchain. And then After that, we have chain code functions. So chain code itself has some basic functions like a main, an init function, and an invoke function. The interesting thing here is the invoke function, and you will see that based on a function and a parameter that is we receive in the creation of this chain code. And as a request, we get the function and parameters. We can do a switch on what kind of other method we need to call, like setup assets or read asset data. We can see a report accident, update report, request quote, offer quote, issue policy, and send claim. These are the functions or the methods that somebody can call on the smart contract. And this is an example of that, the report accident. It will receive a simple model arguments. So it receives 4 arguments where we can create this insurance or this accident report. And you can see a lot of checks here that you can program. And these checks will send an error back. And the error itself, so when you send an error back, it doesn't have a commit, but the endorsement of a transaction fails because of the error. Besides some basic checking of the and conversion of strings to like the floats, because the input parameters are all strings, and even time-based parsing, we can create objects or do even checks if like the vehicle exists. So this is an accident report and the vehicle needs to exist in the blockchain. So you can do a lot of checks. You can, with the get state, you can get something from the blockchain, and with a put state, you can put something on the blockchain. You can also have marshalling of objects. You need to do that a little bit, and then you see here we can do a put state to create the accident in the state. After an accident is successful created, so a report is created, we can send out an event. So we create an object for the event, and then with the set event you can emit this event to the outside world. So everybody that listens on like the WebSockets or that's provided there can act on this event. A lot of stuff there. I've got update report here, and that is more code. Request code it's all the same things, checking things and then storing the information. It's not like very hard business rules. It can be, of course, but it's mostly, is there a record? Can you do this? Can you do that? Those checks you would build into a smart contract. Okay. Let's go further, right? Because next we need to deploy this smart contract code. We can go to chain codes as a founder or the creator of the channel. So the creator of a channel can only deploy chain code to the channel. So this is Acme Services. I can press the button deploy a new chain code, and then we have 2 options, a quick deploy and an advanced deployment. For this, first I will show you the advanced deployment. If I can click on that, I can give the chain code a name. And that should be the same name as the Go file and also the zip file we're gonna upload. So insurance chain, let's put that into my copy so it's everywhere the same name. We can pick a version, let's say v1, or it's better maybe even to have a SAM version there, so 1.0.0. Select the peers that are part of the endorsement of the chain code, or where they want to deploy this chain code to, let's say that. And then for this we need to find the zip file. So I've got the Go app source and then insurance chain. This is a directory, and from this I make a zip file. So just create a zip file and I can upload the zip file. So that's insurance chain, that's the same name, yes. And then we can click on next. This will deploy the smart contract only for this organization, right? The other 2 organizations also need to deploy the smart contract code. So the my channel, I can select the channels I want to instantiate this chain code on this insurance chain, and which peers are part of the endorsement. I don't need to involve both peers, but for performance for being here more secure, I want to do do endorsement on all the peers. If you only want to have high availability and performance, then you only need to deploy the chain code on those peers, and you can choose one peer to be part of the endorsement on the endorsement. Then the most important part is at the bottom is endorsement policy. So in this case, we need to add the identities that are part of the endorsement policy. Click on, I've clicked 3 times on add identity because I want to select all the 3 environments. And then we can say here at basic or advanced policy expression, we can say 2 of 3 organizations need to endorse this transaction or need to endorse transactions. Other things we have is transient map. That's if you want to initialize like private secrets or things like that. When you deploy something, it can be used in the init function. And we have private data collections if we want to store certain information only for specific organizations and not share like pricing agreements. Maybe I only want to do between Acme Services and Autolease. So you can create private collections between organizations, but that you also need to program into your smart contract. So that's a little bit harder to do. So for this case, we don't do that. We click on next, and we're creating this, we instantiating this chain code we deployed on the channel. This will go, this takes some time longer. What it will do is it go to the ordinary services. It does all the configuration there. So the other organizations know they are part of this channel and are involved in this chain code because they need to deploy the same chain code also. So in the meantime that it runs, we don't need to wait for that. We can go to the other organization, go to chain codes, and then also deploy a new chain code. We can do also the advanced deployment here, because with the advanced deployment, we can skip the other steps. So use the same information insurance chain version 1.0.0 needs to be the same, else it doesn't work. Else it doesn't. They are not part of this endorsement, so they need to be the same. We can click on next. It will deploy the chain code, and then in this we can close it because here it now is instantiated, right? So in the background. And the third step, we're back at the founder again. And the third step, you can expose this smart contract to the outside world. So we can say expose it to like one REST proxy, or maybe you can do multiple REST proxies to expose this on. The other thing we can do is we can add peers. So we can add multiple, also the peers to do high availability again for this one. Click on next, and then it will expose the smart contract on both REST proxies. So web application now can even load balance on the REST proxy they are going to use. So this is done, this is successful. If you look at the chain codes, we see that it's there. We've got one version, we can open the information and even see we have one version, this 1.0.0. It's installed on 2 peers and it's instantiated on 1 channel. Now, the interesting part is, if we now go to the channel here, let's refresh for being sure, and go to the chain code, we see that it's immediately instantiated on that channel where it's joined, because that's done by the founder. So once it's installed, it recognizes that you have installed the version and it's instantiated on that channel configuration. So let's see that happening in the real life, right? Let's go to chain codes here for the third organization's Autolease. We need to deploy the same chain code. We can do insurance chain version 1.0.0. We can select both peers again to have it all working together, right? We have them. We can use them. And now the same thing. We can close it, because it's already instantiated. So now, if we refresh it, it should be there, right? So a moment ago it said 0, yeah, with refresh it says it's instantiated. So now all the organizations are part of the channel. We deployed the chain code. They all have the same version, and it's active to be used. All the other organizations can also expose it through the REST proxy itself. So let's say Autolease wants to also expose the chain code. You can go to nodes and then say edit configuration. And in the edit configuration, you can add the channel, so the chain code. I've only got one, and then the endorsing pairs that are part of that. We can submit this, and this means that on this URL, on this endpoint, like this endpoint, this base endpoint, a API is available for this to call this smart contract. Let's do the same for the ERS services, also on REST proxy 1. So now we can call this API. So in this past 30 minutes, I created I joined all the organizations to the same network. I created the channel. I joined everybody to the channel. I deployed the chain codes on all the organizations, and that is now set to be used. So they expose it as in the REST proxy. So what I can now go to Postman. I need to start it up for a moment. And in Postman, I created a project for myself, and to show you that the REST API from that Oracle provides is really, how would you say it? It's really generic. Let's go over. What we can see here is I've got a lot of projects here, but we need to go to insurance chain, and the first thing we need to start is I have some metadata used, and it says it goes to the Acme proxy host, and this is this is something, a variable that I have that I can set, but let's do the simple way for a moment. Let's go to nodes for Acme, and we pick up the proxy service here, go back to Postman, but the interesting thing here is that I can go to insurance chain and then say I want to let's say, do I want to do this? Nah, let's yeah. So we have the current values here for the insurance chain. We have some information here for the Acme proxy. We can edit those. So let's edit the one. And just to be sure, just for this use case, let's set them all to the same one. You can understand that you can set this specifically to the nodes of a certain organization. In my use case, I've got multiple organizations, much more. I've got all the 6 organizations, but let's go to one proxy. The interesting here is that to check that everything is working, I can send a request to get the REST version so it's working. I can call it. I get a message that let's see that in Zoom level, right? That I'm not authorized, and that is because it's inheritance from a parent. I need to change the authorization, and you can use a token for that or basic authentication. So in this case, I can't use this user anymore, but I'm going to use my own user. I need to find out my password. So for the password, I need to sorry that it takes this long. Copy. And then what I can do is I can try to send this again. And then it says version 1.0. So you really need to have a user account on it. Right, so you need to provision users to even be able to call this REST API, and the user also needs to correct rights. So this is I've did the call. What I can do also in the project is to have it everywhere. I can do an edit and then have an authorization there. So Groundbreaker, my account, my password, updated, and then now I can say inherited from parent, and if I do the call again, it should still work, right? Okay. So in this case, I have a transaction there. It uses a different API. It does an invocation on the content type JSON. It has a body, and this is how it looks like. So this is a generic message I'm going to send to this endpoint, and it is the channel is insurance chain. The chain code is also insurance chain. The method is set up assets, and then we have some arguments that's empty. I don't have any arguments, so I can send it on. What I will do is click send here, and then it will go hopefully correctly to the network. We can send it on. And then what it does, it sends the message, and it needs to have proposals. Okay, it fills. And this is something have to do with connections between data centers and things like that. I apologize for this. I need to change something to make this work for a moment. This is the demo codes. I need to go to channels. Let's change I need to change some stuff here. I can go and change I think the version instantiated on channels. This is, sorry guys, but yeah, it shows how it needs to be done. What I can do here is I can upgrade the version, and then I can install a new version. I can install 1.1.1, and with this I can say, okay, peer 0, peer n. I can do the insurance chain, because the problem lies here in the policy, in the endorsement policy. And it goes over all the environments. So I think I missed something, but let's delete the organizations for a moment to do the endorsement. I just want to show you how the API works for this. What I want to go over, I can go over that without that. So you see, it's a generic API, right? So if you build something, it's better to have an API on top of it again to do the arguments. Because if I'm doing a report new accident and go to the information, you see that it uses a different method. So it calls the report accident method. I can do the version number. I think it doesn't matter in this implementation. They're not doing anything with the chain code version yet. And then I've got some arguments there. So the 4 arguments I showed in the code, I'm giving that. So I have the location, the coordinates, a date, and then also the VIN number of a vehicle. And you can see that with reading data. That's also an interesting one. So if you want to query data, you have also a different REST endpoint. This is a transaction query, and the other one is a transaction invocation. Queries don't need any consensus. You query your local state. So it's now instantiated on this one, and it's now active on this organization. Thus, what I can now do is go back to the setup and then try to send it again. Hopefully this works. It takes longer, right? Yeah, it's done. So I get a response back, and this is the event payload that I described, and it shows all the IDs it created and things like that I can use in reading vehicle statuses and stuff like that. So I've got an invocation here, the query, and I'm doing the read asset one, and with this same vehicle ID as I used to create it. So this is created, and then what I can do is query this. And the query will get the same payload. It will get a payload back. So so you really need an API on top of that to have it like something suitable for a UI. But you see all the information based on this vehicle, and also who is registered to it. So who's the register based on this. So this is very interesting, because now I can also query this asset. And get the data out of that registered. I think I made a mistake, but it doesn't exist, so it will get errors back. So it couldn't do a proposal. So that's interesting stuff. How also the checks works in the code. Other things we can do, of course, is additions and things like that, but they are all the same, right? Let's do this on this one. Let's update an accident report. Then we need to have this accident report here. No, doesn't matter for now. You get the picture, right? Based on time, I want to close the demo here. Let's look at the channel. The last thing I want to show you eventually is all the data is on the ledger. So let's go to the ledger itself, and you see all the blocks, all the transactions, if it's a data or not. Let's look at the last one. I did a setup assets, and then I create the information. Let's do another setup of the report new accident. Let's do this one. Let's send it on, because the other one was just a setup of the environments, right? So nothing exists yet. What it does in the background, it also checks the invocation itself, the account, what I can do and not can do. It takes a little bit longer than I expected. I don't know why. But you can see all the transactions here, what is happening, and the data, and even failures, endorsement failures, a little bit. You can see that here. So this is all the information you can. It's available there. If you go to the dashboard, you even also see the endorsements and also the field commits, and yeah, a lot of information there for you to monitor. It's a field proposal. Maybe there's something changed in the data. That's possible. But I want to conclude my demo here. So yeah. Oh, sorry. So thanks for watching my session on at Oracle Code Online. Hope you enjoyed it. If you have questions, you can always try to hit me up on LinkedIn or Twitter, and I will gladly answer your questions. Yeah, thanks for watching, and bye bye.